Okay, well, you can work out the differential equation for each phase, okay? You can work out the solution for each phase based on the differential equation. That's easy. Try to get the ultimate solution because, you know, this thing isn't going to come up quite as high as it did here, okay? Now what's that mean for the next reversal? Is it going to go as low or not as low? You know, the voltage here and the voltage here and the voltage here are not going to be equal. None of them are going to be equal to the others. Right. And they're never going to be. But there's a limiting set of voltages, okay? You might be able to work that out without Laplace transforms, but probably not, okay? We'll have Laplace transforms the last couple of weeks of class, and we'll be able to work this out. Much easier is if you have a driving voltage, and we've talked about it, so I'm just giving you a reminder. And I want you to work as many of these problems as you can, and at least give them thought, because we only have a 2-day interval, and you're not going to master the thinking in 2 days, but I want you to get started on it, okay? So we got the time here, we got the voltage here, and our driving voltage is like this, okay? A sine wave or cosine, doesn't matter, okay? So then what happens? Well, you have some transient voltage, and this really kind of depends on, I'm not even going to try to draw this accurately, just because of time I have to think a little bit, but okay? You're going to have something like this, and you're going to have a long-term solution that you can easily work out. Because you have a simple differential equation that you can easily solve. Just your dq, dt. Well, you got resistance and stuff like that, and I'm not going to recite it. Okay, you've seen it, we've done it. We've solved it. Solve it again, okay? But you have this. And you notice that I've drawn the capacitor voltage so it reaches 0 after the source voltage does, right? Is that accurate?
Yeah.
Why do you think so? Because that's what you saw in lab?
Yeah,
because you understand why it is. Well,
the voltage
you
goes
need to
completely
understand
negative.
what's happening here, okay? You can see that this voltage reaches 0 after this voltage passes through 0, right? Doesn't really pass through, it's an instantaneous change. But if it did pass through just on a very steep curve, it wouldn't change much, okay? So you need to understand why capacitor voltage lags source voltage. That's simple, okay? But the same will happen if you got a sine wave, and the mathematics here is real easy. I mean, you know, real easy if you're differential equations literate, which you are, okay? So we need to work this out and answer a bunch of penetrating questions that I've posed here, and I want you to read them all and think about them.